Hello, everybody. My name is Hello. Welcome to this series where we're talking about programming and design patterns in Python. In today's video, we're going to be dealing with the state pattern, which is a very intriguing, interesting, and a bit hard to understand maybe fully. But I mean, again, it's a very straightforward pattern. Let's go ahead and see what this looks like. States is something a lot of applications use, whether that's Flutter, React, so many things. So you're going to be dealing with states. What are states? Well, that's something that changes, right? That's as simple as I can put it. So just like how solid, liquid, gases are states, those are the same thing under different conditions. So I mean, when you're dealing with maybe subjects like automata theory, you'll have state diagrams, all of that. But to put this very simply, let's go ahead and deal with an example. The best example of states I can think of. Let's say you have an elevator, okay, and this has a floor button. Okay, initially this is in the ground floor. Let's say there are only 2 floors in your building. Now you press the up button, it goes to the first floor. Okay, maybe I can do this here. So you press the first button, or the up button. It only has 2 buttons. Let's assume it has the up and the down button. You're on the ground floor initially. You go to the first floor by clicking the up button, and you click the up button, you can go to the second floor. Now from the second floor, you can, if you press the down button, you're going to go to the first floor. From the first floor, if you press the down button, you're going to go down to the ground floor. So what are the states here? Well, 0 is one state, 1 is one state, 2 is one state. Okay, what are the behaviors of the state here? Well, when I'm at 0, if I press up, my behaviors go at 1. It cannot go down. That is my behavior at 0. Now at 1, my behavior is, if it presses 1, presses up, go to 2. If it presses down, go to 0. Now at second floor, I would say you can't go up, but if you press down, go to 1. Okay, so this is what a state is, and this is the state pattern, basically managing all of these states. And as I mentioned, that each of these states can actually have their own behavior. So the same function might have a different outcome depending on from which state you are calling them. Now all of this we'll try to put into code. Maybe we'll look at a first code example, then we'll look into how this will look like if each of these states are its own class, to provide a bit of light about what this state pattern is. Okay, so let's start with the very basic example of the elevator. Okay, let me put a class called elevator, and at define init self, I am going to go ahead and set a self.state variable, and let me just set this state to be 0. Okay, maybe I can as an integer, that'll be working fine. Okay, then I'm going to actually create an up function self. And what will this up do? Well, what was my condition for up, right? If my state is equal to 2, print you are at the second floor, can't go up. Okay, and else what this will do is print moving up to, maybe we can do self.state plus 1 floor, and then I can update this self.state to be plus equal to 1. Okay, that just work with how it goes with up. Similarly, we can also define the down. Maybe we could just copy paste this code to save time. I'll say if I'm at the 0th floor, you can't go down, else going down to the floor below, and that will just decrease my state by 1. Okay, and that is as simple as you can put this elevator class. Let me just instantiate this class now, and let me just call so I'll do elevator.up and probably go up till the second floor, try it going up again, and then I'll just go down once, then I'll probably go up again, and then I'll go down a couple times, then we'll end it there. Okay, so I'm going to run all of this and I'll show you what the output is like. You can see that initially the state has 0th floor. Once it goes up, it goes to the first floor, then it goes up again, it goes to the second floor. But once you go up again, it says, well, I'm at the second floor, I can't really go up. You press the down button, then it goes to the first floor. You press the up button, it goes back to the second floor. You press the down button, it goes to the first floor. You press that again, it goes to the ground floor. Now, these floors are the different states, but hello, is this the right example of the state pattern? No. This is more of an example to help you understand what we just said, but something that I did mention towards the end of what I just said was each of these states can be its own class. And the advantage of that being is when a state is its own class, it can have its own attributes, its own functionality that other states don't need to have. So if you're going to be adding functionality for specific states, you're going to be adding a lot of if statements, a lot of complexity between this class alone. So we don't want that. Okay, instead of that, we're going to be creating own classes for the. So how that will look like, let me go ahead and define the elevator class, rewrite what this looks like. Now let us go ahead and define init self. Okay, now what happens is I can set a state to set state to my elevator. Maybe I can set that to the ground floor. Okay, what is this state? What is this ground floor? Well, these are actually ground floor is one of the classes which is instantiating that classes. Set state will be a function that we'll have in this elevator itself. So let me just define that set state. Okay, and I'll just do self and state. Okay, now what happens is I'll do self state is equal to state. So that's the same code that we did over here. We have the state attribute, but instead of directly using that as an integer or a string, we're assigning that to an object of a class, which is very important to if you're doing our own behavior, as I mentioned before, right? So for every state object, what I'll do is I will reference back to this elevator. Okay, now this is what that means. So for every state object, which will be the floors, we'll define that function, don't worry. I am going to have an elevator parameter for each of this, and that will be this class itself, so that I can track when it's going between floors or keep track of what floors that it's going. Okay, now let me define an up function. So up of self, right? I can just do self dot state dot up. Okay, so my state object will have its own functionality, which I will go ahead and modify. That will make sense in a bit, but similarly what I'll do is self down, I'll just go ahead self dot state dot down. Okay, this is move the elevator down, move the elevator up with respect to its state, and that will be tracked somewhere else. Now I can also print the state, so I'll do that by get state, and that will be of self again. What I can do is print self dot state. Okay, now since we have ground floor here, let's start with the ground floor object. Ground floor. Now what does the ground floor look like? Well, it has up function. So what will the up function do? It will actually go to the elevator. So it has an elevator attribute that I already mentioned that we're setting from here, correct? So that will be this object itself. So since this is an object that we have, we can actually set that state, set state, and we can actually go to the first floor. Okay, and that's what that does. This is the state set properly. The first floor is something that we've not defined yet, but we can also do go down, and we can actually throw an error here. We just maybe print cannot go further down. Okay, something that we can do. Now that we have the ground floor, let's go ahead and define the first floor. So the first floor has both down and up, right? It can either go to, so that will be self dot elevator, which is the elevator object. We can set that state to go now to the second floor. This will be a class that we have to define shortly. And if it goes down, what I'll do is I will do self dot elevator dot set state from the first floor go to the ground floor. Done. Now I'll go ahead and define my second floor class. What will that do? Well, go up, just print cannot go further up. We are at the second floor. Okay, and similarly I'm going to go ahead and define the down function. Also what that does is it will set the elevator state using that set state function to the first floor. I hope you're understanding what the self.elevator means. That's the elevator that we're defining, and that is nothing but this object itself. Okay, and I hope all of this is clear. Now how do you use this? It's very simple. We'll just add the same driver code that we had before. So I'll go ahead and I will create my elevator Since we used E here, I'm going to be using E1. That's not really important, but whatever. So I will just go up to the first floor, second floor. Maybe I can just copy the same thing and put it back and see what goes on now. Okay, now I also have the get state button because I have to use that in order to see what the state is. So I can always go ahead and do e dot get state. Okay, if I'm able to call this functionality, okay, this will be E1, not E, sorry. So I can just do E1, 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 E1. Okay, and similarly, I just copy the get state in each of these things so that after every up or down operation, we can see what the state of the elevator is. Okay, state of that elevator is. Okay, now if I run this code, you can see that actually what happens is initially it's at the ground floor. Once it goes up, the state will be a first floor object. Okay, I'm just printing the object itself, but so when you're printing the object, it'll actually show you what the name of the class is. We're using that as the state. Okay, so it says it's at the first floor, so it is an object of the first floor class. Once it goes up, it says it's the second floor class. Now it does tell you it cannot go further up, and when you get the state doesn't change. It remains at the second floor when you try to go up from the second floor. Then what do? We go down to the first floor, and that's where you get this, and you go up again, you get the second floor object, and then you go down, it goes to the first floor, and you go down, it goes to the ground floor. Now each of these states, here they were just integers, but here they are objects of classes. So these up down functions are very simple, but you can add a lot more complexity within how these floors work, about how these up and downs work in specific floors. So once you set that state, that's something that you're free to do if these are classes by themselves. So that is the difference between this and this implementation that we had. So this is the state pattern. I hope you're able to get something out of this. If this video helped you, do hit that like button. If you guys have any questions for me, let them know down in the comments. I'll try to answer them to the best of my abilities. Now all of this code again will be available in our GitHub repo, link in the description. Thank you so much for watching. I'll see you in another video. Until then, bye.